This is question number 17 on the June 2013 non-calculator paper. There's a fair bit in this question, and I'll say this before we start. This question was one that wasn't answered particularly well. A lot of people found difficulty with this, but it's actually a question which is pretty straightforward if you break it down into stages. So let's look at this first. Samit has a pond in the shape of a prism. And what do they mean by a prism? Well, it's got this trapezium shape front, and it goes back 1 meter each way, so that's why it is a prism. The pond is completely full of water. Samit wants to empty the pond so he can clean it. Samit uses a pump to empty the pond. The volume of water in the pond decreases at a constant rate. The level of the water in the pond goes down by 20 centimeters just 30 minutes. Work out how much more time Samit has to wait for the pump to empty the pond. Okay, so they want us to work out how much more time, right, he has to wait for the pond to be emptied. Now, that last bit is a bit that a lot of people have missed. Right? How much longer does he need to wait? Not how long it'll take to empty the whole pond, but it's already taken 30 minutes, and you need to work out how much longer, how much more time is it going to take altogether. All right, so we need to actually break this down into stages. The first bit is to work out the volume of the pond, and to do that, I'm actually going to use bits of this diagram. Now, once I finish that bit, I think I could be able to move on a bit. But if I look at this, so the volume of the pond, I need to work out the area of the trapezium and then times it by the length. Now, the area of the trapezium is the area of this front face here. Okay, and to work out the area of the trapezium, you add the parallel sides, you times it by the distance between them, and you divide by 2. And that is in the formula sheet, so you need to be familiar with that and make sure you can do it. The distance between them, it's going to be a half times the distance between them, which is 2 meters, times the parallel sides, that's 0.5, that's 1.3. So you should be able to do that. And how far back does it go? Well, it goes 1 meter back. Alright, so that there will help me work out the volume of the pond. And really, that's a pretty simple calculation because a half of 2 is 1. 1 times that is going to be working out to 1.8 times another 1. So really, the volume of the pond is going to be 1.8 meter cubed. Now, make sure you do that. Showing this information alone is going to pick you up some marks, right? So you need to make sure you actually do the stage and you get this bit. Now, if I go back to the question said the level of the water in the pond goes down by 20 centimeters in the first 30 minutes. So the volume of water removed in 30 minutes, how much is that equal to? So if I think about this, the volume of the water the level of the water in the pond goes down by 20 centimeters. So it'll go down by 20 centimeters. Now remember, that there is 0.5 meters. That's what, 50 centimeters. So I know it's not going to go any lower than that block at the top there. So that's where the water level sort of gone down to, 20 centimeters. After 1 hour. Now 20 centimeters is 0.2 0.2 meters. And that is going to be like a cuboid, a rectangular cuboid, the block of water that's been removed. So to work out the volume of water removed after 30 minutes, I'm going to do 0.2, that's how much it's gone down by, right, times that rectangle at the top, or the area of the rectangle at the top, 1 times 2. So length times width times height. And what does that work out to? 0.2 times 1 is 0.2, times it by 2 is 0.4 meters cubed. So 0.4 meter cubed is removed in half an hour, in 30 minutes. So in 1 hour, you're going to remove 0.8 meters cubed. Now the volume of the whole thing is 1.8 meters cubed. So if we could break this down, what we need to do is to consider how we break it down. So how are we going to break down or look at how long it takes this pump to remove 1.8 meters cubed if in 1 hour it removes 0.8 meters cubed. We know that in half an hour it removed 0.4 meters cubed, and if I do it again, a quarter of an hour, it's going to remove 0.2 meters cubed. So, actually, thinking about this now, the question says, work out how much more time Samit has to wait for the pump to empty the pond. So after 30 minutes, so if I go after 30 minutes, how much water is left in the pond? Well, they've removed 0.4, so given that the volume of the pond altogether was 1.8, after 30 minutes, you're going to have 1.8 take away 0.4, which is 1.4 meter cubes, is the volume of water in the pond. How long would it take to remove 1.4 meter cubed of water from the pond? And in fact, if I look at this, so it takes 1 hour to remove 0.8, it'll take 1.25 hours to move 1 liter, and half an hour more, 1.75 an hour. So to remove the remaining 1.4 meter cubed would take 1.75 hour. That's the same as 1 hour 45 minutes. Yeah, because these three add up to 1.75, and these here add up to 1.4 meter cubed. Okay, that was a coincidence that these did. I thought I'd have to use these in different chunks to work it out. However, this actually works out a lot more straightforwardly than you'd think. This is a challenging question. As I said, not a lot of people got this correct. 6 marks is a fair few marks, so if you get it completely right, yeah, it puts you in good stead for sort of doing quite well on this paper. Okay, go through this several times, make sure you understand it, make sure you know how to do it, and make sure you're able to get near enough full marks in it.